I am Dirk-Jan Faber, developer at Victron Energy, maintainer of the Node-RED nodes that ship with our Venus software. Today I'm going to look into the Node-RED flows of the camping site, the Blauwe Haan. On our main channel there's a video which shows the site on a more practical level and how our Victron equipment is being used there. Let's get started and open our VRM website of the Blauwe Haan website and start Node-RED from there. So this is the VRM site of the Blauwe Haan. If we want to go to Node-RED, we have to go to the Venus OS Large menu. If you don't have this button, then you're probably not running the large image. I'll show you later on how to install that. But let's start up Node-RED here. You can click on the tile and then it opens Node-RED. First things that we spot in this Node-RED flow, that it has several tabs. Not all labeled that clearly. Well, the default name is flow and then a number. And you can adjust it by double clicking on it and then adjusting the name. The developer used a bit of a combination between English and Dutch, which is okay, of course. And by the looks of it, he had a bit of a wider monitor. So the flow does not fit in my screen in one go, but you can scroll. So let's see what all these flows do. There's a temperature control. Oh, this one is in the main video. There's a the fan is mentioned in the container that is being switched on and off depending on the temperature of the room. I am fairly sure that this is the flow that is responsible for it. This looks like a debug flow. There's here a battery guard flow. Now we can look at the temperature flow first. This is a simple one, a relatively simple one. It checks the temperature in the container using the temperature node. Here on the left you see all the Victron nodes, and this is the temperature one, which is measuring the temperature in the room. At the moment it's 20 degrees. It's always easy that last red number is shown below, which makes it a lot easier to debug. Here's a switch node, which checks depending on the temperature, I would assume. But this looks at the flow relay too, which is a context variable, which is being stored here. The context is a piece in the flow where you can store variables and use them at a later point. This part is reading out this node is reading out the state of the relay, which is open right now, and it stores it in this global context, or in this flow context. A flow context is a context which is only valid within this flow. So that value, this one has different ones, different values. So there's also a global context, which could have been used here as well, because as soon as you add a Victron flow to the canvas, it also stores the values within the global context. So for this one, it would save it in the system relay in the state, which has the same value as the local one. But there's no good way or bad way to do it. Everyone has his own way. Depending on the state of the relay, it checks the temperature. So if the relay is open right now, it goes into the second path, and then it does a temperature switch. If the temperature is above 41 degrees, then it outputs to the first exit output. If it's below or equal to 33 degrees, it goes into the second one. Well, it was 20 degrees right now in that room, so it will go into this part of the flow, which sets the message payload to the value 0, which opens the relay. So if the temperature is above 41 degrees, then it would have gone to this part of the flow, set the message payload to 1, and then close the relay. This is a simple way of controlling the temperature of a room and switching on and off a fan. So let's look at another part of this flow. So this first part, this first tab shows a more complex flow. By the looks of it, it uses these context values again, storing the latest values, and here it injects once as soon as the flow gets deployed. It injects a value of a set point max of 17,500, and it also does the same for the set point minus and stores it into the flow or into the context. This is the same. This node reads out the SOC state of charge of the battery. Then we have another switch node, which probably does something depending on the SOC value, and it does. If the value is above 37, it goes to output 1. If it's between 35 and 37, it goes to output 2, and if it's below 35, it goes to output 3. And depending on the path of the flow, it probably sets some other values, like here. This is, if you hover above it, you can see also simply where your flow is going. At the moment it's 38 SOC, so that would be it's taking the top path. This forces the grid set point to the minimum value which has been stored initially in the context, 1500. And then here it splits. It goes into a debug node. It goes into, it changes the payload once again to put a 0 into the feed access DC coupled PV into grid. Below you see what it does. You can also see it in the documentation of each node. So depending on your node, it will show you a different documentation. So if we go feed access power, where do we have it? Here it is. So if you send in the value 0, then it won't feed excess DC tied PV yield into the grid. If it's set to 1, then it will feed excess PV into the grid. In this case, because the SOC is above 37, if I recall correctly, it's forcing the system not to feed in excess PV into the grid. It also outputs its value into the debug node, which you can see on this tab, that's 1500, which I mentioned before. It also goes into this dead end, and it goes into the grid set point. So it sets the set point depending on the state of charge of the battery. If the state of charge drops a bit, then it goes into this part of the flow. It calculates a set point. How does it do that? It does it by taking the grid power and the battery power, subtracting the battery power from the grid, and that will be the new set point, puts it into the payload and outputs it. What I would personally do is add I can do that node status here, which helps you to debug a bit. Well, let's make it green, and shape can be either ring or dot, and then the text will be the message payload. So if we add this and deploy, we probably won't see anything direct because the state of charge is still going alongside this path, but as soon as it hits this path, then this node will get the information below as well, which is a handy trick for debugging, and you can see the value that is going into the system. Depending on the state of the value, it probably takes a different route again. Now, if the calculation is between the minimum and the maximum value, then it goes to output 1. If it's above, or if it's below the minus value, then it goes to output 2. If it's above the maximum value, then it goes to output 3. If it's below, then it enforces it to be the lowest value. If it's above, then it enforces it to be the maximum value. And then it also puts it into the grid set point. The above one was the calculated value, which goes directly into the grid set point. It also goes into the debug node. So that's where you could see it as well, the value. And there's another trick. If you click here, then you can, and the debug node will also start showing the value that's going in, which is a easy way. Then you don't have to open this and this tab and look for the value, but you see it right away. Depending, here's another cross point. It will also set a grid feed in to 200, and it will set to feed the excess DC coupled PV into the grid. And here's another dead end, which is probably a bit of a partly debugging code or still in development. And by the looks of it, this big timer thing is also going into a debug node, and it's not doing anything. I can check. Well, big timer is an extra node. You can install it via the node pallet. Via the pallet manager, manage pallet. You can see some extra nodes got installed. There's some default ones which get installed with Venus. And you can install some extra ones. I noticed on the second flow that there's also some dashboard things going on. Go to this one. You can see that this flow adds some dashboarding options, which is coming from the dashboard node. As soon as you install this Node-RED dashboard, you can do it via the Install tab. Search for, say, dashboard. Board. Well, this one is already installed, but if you want to install another one, you can just click Install. Takes a while, so be a bit patient. Then after a while, a pop-up appears on top of the screen that you got new nodes installed, and you can on the left side you find extra nodes you can use. Well, the dashboard has already been installed, so let's take a look at this flow. As soon as you deploy the dashboard, you can also, from a VRM side, you can also open the dashboard directly, which is handy. This works for both this dashboard and for dashboard version 2, which is the successor of the first Node-RED dashboard. Well, what does it do here? It uses the Victron nodes to read out some values. It also uses so this reads out the solar yield in watts. It reads out the Fronius, and it reads out. It uses energy meter. It sums all those values. It limits. This is a sum node, which is also an extra installed package. And it limits the output by 1 value per second. It goes into debug 1. This debug node is currently inactive. You can say I want only on this flow, and you can activate it by pressing this button. And then you see the value going. It outputs it to a gauge with a range set between 0 and 50,000. And it also outputs it into a line chart. The rest of this flow is quite similar by the looks of it. It gets some power from the grid meter. It takes the charging state, probably state of charge. Yeah, the state of charge from the link shunt. It puts it also in a line chart and in a gauge. You can see it on the icon which type of chart is used. This is also the current going through the battery. It sums here the AC consumption, also in a usage gauge. And then it has some debugging things. It also sets a power limit, and it does it by using an inject node. Using a inject once after first 0.1 seconds. And then, so as soon as you hit deploy, then this node outputs the value once. This is probably for manually enabling and disabling the PV inverter. here it saves the flow relay value into the flow context. This looks also a bit like debugging. Oh, it sets the grid set point initially once to 1500 to the minimum value. And there's a debug node floating around here. Yeah, let's look at the next one. This has some values. This could be for debugging or just it makes it easy when you're developing the nodes. If you just grab a node and put it onto the canvas, you can see the values already, and that helps you getting a bit of more of a feel to of what the system is doing at the moment. This uses the sum node and puts it in a local context again. It does the same for the grid power. Yeah, well, it doesn't really look like this part of the flow is actively used. We've already looked at this one. Flow free. Well, this looks for debugging as well. Then we look at the battery control flow, which is a bit more complex, but nothing too fancy. It checks the battery voltage. Well, a bit of a debugging. And there's a voltage switch. You can double click it. Well, it's the same logic, which is used in the other flows as well. So I'm not going to look too deep into that. Depending on the battery voltage, it calculates a charging current here. It sets the payload to 0 or it sets it to 300. Can set it to max discharge, payload 0, and it calculates inverter wattage. So here you could also add this node status again, and this one will probably be active because of all the paths going into this node. Well, you can choose some different colors. Yellow, green, red, and blue work. So from the top of my head, the shape, we had a dot, we had a ring, and you can use a dot as well. And the text, well, it can be anything, but message.payload is the most useful one. Yeah. Let's see what it does if I deploy this. I'm not sure. Oh, well, there's only one path going in. So at the moment, this one is also not showing it. Let's copy this and put it in this one as well. Closed. Now what is the battery voltage? It's going into the low path. Now in this path. Oh, it's between this path and the third one. So it's not showing here right now. So let's see, then if it's active here, then it should set the payload to 300. Oh, yeah, well, it says 300, but it's actually 950, which is not the way that I would have thought, would have expected. So I would advise to change this value to be equal to the number which is shown here. But I'm not going to change the flow right now, because I'm not sure if the 950 or the 300 is the correct value. Probably 950 because it's there as well. Then I can show you another trick. If you don't have a wide monitor, then there are some tricks on getting your flow a little less wide. You can use the link nodes, which aren't used on this side, so I can show you how to do it. You have a link out and a link in. It's easy to mix these up, but these two can be interlinked, which means you can use it to make your flow less condensed. So if I put this part here, this part here, and say instead of going through this one, go into this one. And then if a message arrives, it will go via this link to here. So instead of going here, and there we can eliminate the need for this part of the flow. If we take another one, let's move these a bit below. Let's take another combination of these two. Interlink these as well. One there. And one there. If we link these together, then we remove the need for this link, and now we can move this one here, this one here, this one here. Let's line these up a bit more, and then move this node here. Then all of a sudden it fits in on your screen. You can also name these links. What was it? Relay on or off. One is close the relay. Say close relay. And the other one, we call it open relay. So if you hover above it, then you see directly what it's doing. And if you deploy it, then functionality of the system is still the same, but it's, at least for me, it's less cluttered on the screen. I think we've looked at all of the flows right now. As promised, we can look at the dashboard, which is here. This is the dashboard of the screen. As mentioned before, it has some gauges and a line chart. You can access this directly from the VRM side by clicking on the right tile. From the VRM side, you can directly open the dashboard using this tile. If you don't have this tile, then you don't have the dashboard pallet installed. Install it, deploy it, and you get this extra tile. The same goes for the dashboard version 2. Then I mentioned that that if you don't have this large button here, you probably have the wrong firmware image installed. You can check that. We're going to the new UI. Yeah, well, this is in Dutch, but this is settings. Go to firmware, online updates, and there's the image type, and this is set to large. If it's set to normal, then you don't get that menu option. If it's set to large, then you get it. And below in the Venus OS large, you can activate Node-RED. So if it's not activated, uitgeschakeld means deactivated. You set it to activated, then Node-RED will start, and you get the tile from VRM. So that's how you get started. Thank you for watching this video. It was nice to take a look at how the camping site uses Node-RED to steer its equipment. Yeah, thank you.